Measuring distance using apparent and absolute magnitude. Recall that apparent magnitude is how bright a star appears in our sky. Whereas absolute is how bright a star would be if it were 10 parsecs away. PC is the abbreviation for parsecs. So if we know both of these values, then we can determine the distance. Or if we know the apparent and the distance, we can determine the absolute. So we can go both ways. Apparent's the easy one. We just need to look at the sky and we'll know that. It's how we know absolute or the distance that's a little trickier. So there's three possibilities. Let's say you have a star that is exactly 10 parsecs away. Well, then it's easy. By definition, the absolute magnitude is going to equal the apparent magnitude. And looking at our examples here, Vega is pretty close. It's 7.7 parsecs, so almost 10 parsecs. And you can see how it's drawn here that the apparent and the absolute are equal. So Vega, we're pretty close. Now what if it is closer than 10 parsecs? Well, if it's closer, then it's going to look bright. But remember the way the magnitude scale is set up, that's going to be a small magnitude number. So the apparent is going to be bright. So that's going to be a small number compared to the absolute. So our sun is an example of that, much, much closer than 10 parsecs, 0.000005 parsecs. And here we see our apparent magnitude, very bright, absolute magnitude, very faint. So our sun is a primary example of appearing much, much brighter than the absolute. For our sun, apparent magnitude, as we saw, was about negative 26. Absolute magnitude, looking at the relative scale here, looks like it's about fifth magnitude for the absolute value for our sun. So here's an example where negative 26 is a smaller number than 5. And so that's what we mean by little m being smaller than big M. So apparent is a number that is smaller. The appearance is brighter. And that's an awful system to use, and I know it, but it's what we're stuck with. And then our last scenario, if the distance is farther than 10 parsecs, then it's going to look fainter. Which means a larger magnitude number. So Polaris here, we've got an example, 133 parsecs away. Here's our apparent magnitude. Polaris, reasonably bright in the sky, looks to be about second magnitude. But the absolute magnitude of Polaris is about negative 2 or 3 based on the scale. We'll call it negative 3. So our apparent magnitude number is going to be a larger number. So 2 is bigger than negative 3. So if we know the apparent and absolute, we can get the distance. Or if we know the apparent and the distance, then we can get the absolute. So that's two different ways we can use this relationship to determine distance or to determine the absolute magnitude.